Welcome to the lesson on absorbed glass matte battery, commonly abbreviated as AGM battery. In this lesson, we will look at the history, chemistry, and construction of absorbed glass matte batteries. Let us look at our lesson objectives. By the end of this lesson, you will be able to describe the structure and working principle of AGM batteries. Next, you will be able to explain the role of AGM batteries and BEVs. Then, you will be able to compare AGM batteries with flooded lead acid and lithium-ion batteries. Later, you will be able to outline the chemical reactions involved in the charge and discharge cycles of an AGM battery. Finally, you will be able to identify the advantages and limitations of AGM batteries. An absorbed glass matte battery is a type of lead-acid battery where the liquid electrolyte is absorbed by a fiberglass mat between the battery plates. Even though BEVs use lithium-ion batteries, many BEVs have a 12-volt AGM battery. This 12-volt battery powers essential low-voltage electronics like lights, radios, and computer systems. Understanding how to maintain or replace this AGM battery is essential for technicians. AGM batteries share some similarities with lithium-ion batteries regarding their sealed design and overall function. Grasping the principles behind AGM batteries, a well-established technology, can provide a foundation for understanding the complex lithium-ion batteries used. Let us now look at the history of AGM batteries. Concorde Aircraft Battery, located in San Bernardino, California, developed AGM batteries in the late 1980s. AGM batteries were pioneered in military applications like naval helicopters and fighter jets. These batteries aim to be a superior alternative to expensive nickel-cadmium batteries in aircraft, offering better performance in warm weather and resistance to vibrations. Unlike flooded lead-acid batteries with liquid electrolytes, AGM batteries use a glass mat separator that absorbs the sulfuric acid solution, making them leak-proof and spill-resistant. AGM batteries are also known as recombinant batteries because the oxygen produced during charging recombines with the lead plates, minimizing gas emissions and the need for water refilling. AGM batteries' sealed design and leak-proof nature make them ideal for applications where the battery is located near passengers, such as in the trunks of a vehicle. Like their flooded lead-acid counterparts, AGM batteries rely on sulfuric acid in water solution as the electrolyte, with a fully charged battery containing 64% water and 36% sulfuric acid. During discharge, sulfate ions travel from the electrolyte towards positive and negative electrodes. Simultaneously, oxygen gas is released from the positive electrode. The released oxygen combines with hydrogen ions to form water within the battery. Theoretically, when all sulfuric acid is depleted, the reaction stops, leaving lead sulfate on the electrodes and pure water in the electrolyte, signifying a fully discharged battery. As the lead sulfate forms on the electrodes, the battery's internal resistance increases and the electrolyte's conductivity decreases, reducing overall battery performance. During charging, sulfate ions previously bonded to the electrodes are released back into the electrolyte solution. Oxygen from the electrolyte is used to form lead dioxide on the positive electrode, essentially reversing the discharge reaction. The defining feature of AGM batteries is their use of a glass microfiber mat separator that absorbs and retains the sulfuric acid electrolyte solution. The compressed absorbent material holding the plates enhances the battery's ability to withstand vibrations compared to flooded lead-acid batteries. A low-pressure venting system is integrated into the AGM battery case. This valve releases excess gas pressure during overcharging to prevent the case from bursting. The valve allows internal gases to escape but seals the battery, preventing outside air from entering. This limits corrosion and extends battery life. AGM batteries perform poorly in high-heat environments as they generate heat internally faster than flooded lead-acid batteries, and they also have a lower ability to dissipate heat, leading to potential overheating issues. AGM batteries are generally 2 to 3 times more expensive than flooded lead-acid batteries. They are spill-proof as AGM traps the electrolyte, preventing leaks even if the battery breaks. The non-liquid electrolyte lowers the battery weight, potentially reducing shipping costs. AGM batteries can withstand freezing temperatures better than flooded lead-acid batteries. They have simple charging, using the same charging voltages as flooded batteries. They have a powerful performance as they have an extremely low internal resistance, enabling high cranking currents for starting engines. AGM batteries generate minimal heat during charging and discharging cycles, reducing thermal stress. AGM batteries have a very low self-discharge rate, 1 to 3% per month, that minimizes power loss during storage. They are safe for indoor use as hydrogen emissions are very low, below 4%, even under overcharging, making them safe for enclosed spaces. They are environmentally friendly, as lead-acid batteries, including AGM, have a well-established recycling infrastructure and a high recycling rate of 97%. Let us look at our lesson summary on absorbed glass mat battery. AGM batteries are sealed lead-acid batteries that use fiberglass mats to absorb the electrolyte, making them leak-proof, spill-resistant, and suitable for passenger vehicles and enclosed spaces. In BEVs, 12-volt AGM batteries power essential electronics like lights and computers, even though the main propulsion system uses lithium-ion batteries. AGM batteries originated in the 1980s for military aircraft use and offer vibration resistance, high cranking currents, and better cold weather performance than flooded batteries. During discharge and recharge cycles, chemical reactions involving sulfuric acid and lead sulfate occur, with a venting system to manage gas pressure and prolong battery life. AGM batteries are low maintenance, recyclable, and safer for indoor use, but they are more expensive and less heat tolerant than other types of lead-acid batteries. Thank you.